The first lesson in our chemical reactions and mole unit is on interpreting chemical formulas. We just have a single learning target for this lesson, and that is we want to be able to read chemical formulas to determine the number of atoms present of each element. I would like you to think about the formula for water. When someone asks you for the formula of water, there's probably one of two things that come to your mind. First of all, you might just think H2O out loud, or you might just think that in your head, or you might see the formula for it, which we would write like this, with the symbol for hydrogen, the capital letter H, followed by the subscript number 2, and then the symbol for the element oxygen, the capital letter O. But what we want to get at in this lesson here is what actually does that formula mean? That formula H followed by the subscript 2 followed by O. What does that mean? Well, a couple things we can think about. One would be the Lewis structure for water, and this is something we've learned how to do. The Lewis structure would look like this, and you can see that there are two hydrogen atoms represented by the two capital H's there, and the one oxygen atom. Or a picture of a water molecule, not an actual picture, but a representation of what another way a water molecule might look, would be like this here. You see we have the two atoms that are shown in white, that the hydrogen atoms, and then the one shown in red, the oxygen atom. So what we're getting at here is that this formula tells us that there are two hydrogen atoms, and there is one oxygen atom in every particle of water. So what we want to do is we want to start developing some rules or guidelines for us being able to interpret formulas to determine the number of atoms of each element. So here are the things we want to know. First of all, the subscripts, and those are those small numbers written below the line of the text that follow the symbol. What those tell us is that they indicate the number of atoms present of that element. If there is no subscript after a symbol, for example, if you think of the formula H2O, there is no subscript after the letter O for oxygen. What that tells us is that there is one atom of that element in a particle of that substance. So let's look at some examples here. For each of these formulas, we're going to do three things. First, we're going to determine the number of elements that are present. So we want to look at the formula and say this is the number of elements that are in the compound. We want to give the name of each element, and remember that you can just look at your periodic table for. You don't need to memorize any of those. And then we also want to indicate the number of atoms that are present of each element in that compound. So the first one here, we have C3H7N2O6. So first thing, ask yourself, how many elements are present here? And if you look at this formula, you'll see that there are, in fact, 4 elements. I know that there are 4 elements, basically because I see 4 capital letters. Recall, with symbols of elements, every symbol starts with a capital letter. So if I see 4 capital letters here, C, H, N, and O, those are all different elements, and that tells me I have 4 elements there. Next thing, we want to know the names of those. Well, just look at your periodic table. Look at these symbols and you'll find the names of them. You'll see that the C is carbon, the H is hydrogen, the N is nitrogen, and the O is oxygen. Lastly, we want to indicate the number of atoms of each of those elements that are present. Well, it just so happens here that every one of those symbols has a subscript that comes after it, and recall that those subscripts tell us the number of atoms. So in this particular compound, in a particle of this, there would be 3 carbon atoms, there would be 7 hydrogen atoms, 2 nitrogen atoms, and 6 oxygen atoms. Let's look at another example. Here we have Na2O. So first of all, ask yourself how many elements are present. Well, here I see 3 letters. I see N, A, and O. But remember, the symbols have to start with a capital letter. So this lowercase letter A is not a new element. That is a 2-letter symbol, the symbol Na. And so here there are just 2 elements. There's one that has the symbol Na, the second one has the symbol O. And if you look at your periodic table, you'll see that Na stands for sodium, and as we know, O is oxygen. So there are 2 elements, one being sodium, one being oxygen. And then as far as the number of atoms present, notice that subscript 2 comes after the symbol for sodium. So there are 2 sodium atoms. And there is no subscript here next to the oxygen, so there is just 1 oxygen atom. Here's another example. CO. There are no subscripts here. Some students have trouble interpreting this in one of 2 ways. First of all, some students will look at that and say, well, there's only 1 element there, it's just CO. But recognize that they are both capital letters. If you have a capital letter, that's the start of a new symbol. So there are, in fact, 2 elements there. One that has the symbol capital letter C, the second having the symbol capital letter O. And if you recall, we've already seen both of these symbols so far. Carbon is capital letter C, and the oxygen is the capital letter O. The second way that students will have trouble interpreting this is the fact that there are no subscripts. Some students will look at this and say, well, I don't know how many atoms are there. There's no subscripts there. But remember, if we just default back to our rule, if there is no subscript that comes after the symbol, that means there's 1 atom. So there's 1 carbon atom here, and there's 1 oxygen atom. This, in fact, we'd call carbon monoxide. Dangerous stuff. Don't want to be breathing that in. You'll end up in the hospital, or even worse. All right, another example. LiHCO3. You'll notice there that there are 4 capital letters. I see a capital L, H, C, and O. Yes, the capital letter L is followed by another letter, but there are 4 symbols there. That means there are 4 elements. The identity of those elements being lithium, hydrogen, carbon, and oxygen. And then as far as the number of atoms of each element, notice after the symbols for lithium, hydrogen, and carbon, there are no subscripts after those symbols. So there's 1 of each of those, 1 lithium, 1 hydrogen, 1 carbon atom. And then the subscript 3 after the symbol for oxygen indicates that there are 3 oxygen atoms. Alright, I have a couple I'd like you to practice here. You're going to be doing the same thing. So once the formula comes up, pause the video, answer the questions, and then play the video to see if you got them correct. Alright, the first practice problem is COF3. Pause the video. So you've had a chance to practice this on your own. The first thing I hope you noticed here was that this O here is in fact lowercase. It's not a capital letter O. So that O goes with this capital letter C for the symbol. So that is not carbon. It's also not carbon and oxygen. That whole thing is 1 symbol. So that is just 2 elements. There are 2 elements there. I see the symbol CO. I see the symbol F. If you look at your periodic table, you'll see that the element that has the symbol CO is cobalt. So there's cobalt atoms there, and we also have fluorine atoms. As far as the number of atoms, we have 1 cobalt atom because, again, there's no subscript that follows the CO. And then there are 3 fluorine atoms to match the subscript there after the F. Alright, another one to practice here. Again, pause the video after you see the formula. Here the formula is Rb3PO4. Like on the last practice problem, you'll notice that the first element here has 2 letters in its symbol. I have a capital letter R followed by a lowercase letter b. So that is all 1 symbol. It's 1 element. So this compound in total has 3 elements. The 3 symbols I see are Rb, P, and O. Each of those referring to rubidium, phosphorus, and oxygen respectively. As far as the number of atoms that are present, I can see that there are 3 rubidium atoms because there are the subscript 3 there after the symbol Rb. Just 1 phosphorus atom because there's not a subscript that comes after it. And then 4 oxygen atoms because of the subscript 4 that comes after the O. Alright, going back to our rules here for interpreting formulas, we've seen examples of the subscripts. We've seen examples where there is no subscript after the symbol. One thing we have not seen yet is this. It addresses this question. What if the symbol contains parentheses? What if there are parentheses? If you're not sure what I'm talking about, just take a look at these 2 symbols. We have BaOH2, where the O and the H are together within the parentheses, and the 2 is outside the parentheses. And then we have this symbol here, AlNO33, where the NO and that first subscript 3 are in the parentheses, and then the second 3 comes outside of the parentheses. What in the heck do we do with those? Well, we'll see some examples here to help you interpret those formulas. The basic idea is this, is that the subscript that comes outside the parentheses applies to all the elements that are inside the parentheses. So in other words, this subscript 2 here applies to both the oxygen and the hydrogen, and then this subscript 3 here, the one that's outside the parentheses, applies both to the nitrogen and to the oxygen, and actually more specifically the O3. It refers to all of that. So we'll interpret those here in our next examples so you can see how to work with those. So we're going to do the same thing we did before. We're going to determine the number of elements present, the name of each element, and the number of atoms of each element. So the first one we'll do is that first one we saw on that last slide here, BaOH2. And here's the best way I can encourage you to think about this. When you see parentheses, just write everything inside the parentheses the same number of times that you see the subscript. So when we have BaOH2, think of that as BaOH, where I write the OH twice, because that subscript 2 applies to everything inside the parentheses. So when we see the parentheses OH and then 2, that tells us we have 2 of those OHs. So as far as the interpretation goes, we have 3 elements there. I can see 3 symbols. I see Ba, I see O, and I see H. So we have barium, oxygen, and hydrogen. And then as far as the number of atoms, if I look at this way that I wrote it here, the BaOH, there is no subscript after the Ba, so there's just 1 barium. And then sometimes students will look at that and say, well, how many oxygens? Is it 1? Because there's no subscript, but do notice the symbol for oxygen appears twice. I have 1 here, and I have 1 here, so that's a total of 2 oxygens. So there's 1 barium atom, there are 2 oxygen atoms, and likewise, there are 2 hydrogen atoms, because I see 1 hydrogen here, and I see another hydrogen here. So a total of 2 hydrogens and 2 oxygens. Alright, let's look at that other one that contained the parentheses, the AlNO3, 3. So again, think of it not as the parentheses with the 3 outside of it. All we need to do to think of it is think of it as everything inside the parentheses I'm going to write 3 times because that's the subscript that comes after it. So think of it as AlNO3, NO3, NO3 is a good way to think of it. So here there are 3 elements. There's aluminum, which is Al, there's nitrogen, which is N, and there's oxygen, which is O. Side note here on the symbol for aluminum, many students will look at that symbol and think of capital A, capital I. Remember though that the capital letter I would not just be a straight line up and down. You'd also have the 2 horizontal lines at the top and the bottom. So the lowercase letter L, which is the second letter in aluminum symbol, will just be that straight line. So that is not 2 separate elements there. That's just 1 element, aluminum. Alright, as far as the number of atoms here, looking at our formula, there's only 1 aluminum atom. There's no subscript that comes after it. So there's 1 aluminum atom there. Nitrogens, there are 3. I have 1 nitrogen here, I have another one here, I have another one here. And after each nitrogen, there is not a subscript. That 3 that we see there comes after the oxygen. So it only applies to the oxygen. The nitrogen, 1 here, 1 here, 1 here, there are 3 of them. And then as far as the oxygen is concerned, there are 9 oxygen atoms. How do we get 9? Well, I see that there's 3 here, there's another 3 here, there's another 3 here. So 3 plus 3 plus 3 is in fact 9 oxygen atoms. Some of you might be thinking, well, isn't there a little bit of a faster way to think about this, or do I really need to write all these letters out, Al, NO3, NO3, NO3? You don't have to. And here's what some of you might be thinking. It's this. Aren't we just multiplying here these subscripts with the parentheses? And the answer is yes, we are. Notice I have NO3 and I'm just multiplying it by 3 because that's the subscript that comes outside the parentheses. Inside the parentheses there's 1 nitrogen atom. 1 times 3 is 3. So I have 3 nitrogen atoms. Inside the parentheses, there are 3 oxygen atoms. 3 times 3 is 9. And that is exactly how you could think of that as well. All right. I have a couple more for you to practice here. Like before, pause the video once you see the formula, try it yourself, and then play it once you have come to an answer to see if you got it right. All right, first one here we have is Fe2SO43. So pause the video, give it a shot. All right, hopefully you've arrived at these answers. There are 3 elements here. I see 3 symbols. I see Fe. Again, notice that E is lowercase, so that is all one symbol. I see S, and I see O. Those 3 elements are iron, which is Fe, sulfur, which is S, and oxygen, which is O. As far as the number of atoms that are concerned, we would have 2 iron atoms. Okay, this one, for the iron, I don't need to worry about the parentheses because the iron's not in the parentheses. The subscript 2 coming after it indicates that there are 2 iron atoms. And then I have 3 sulfur atoms. As far as how we get that, remember, when I see this SO4 inside the parentheses and the 3, I can just think of this as SO4, SO4, SO4. So there are 3 SO4s there, each of them having 1 sulfur. 1 times 3 is 3. And then for oxygen, I have 12 of them. I have 12 because I have 3 SO4s, each of them having 4 oxygens. So 4 plus 4 plus 4, or 4 times 3, is 12. All right, another example. Again, pause the video after you've seen the formula here. NH42O. In this example, there are 3 elements. There are 3 elements. I see 3 capital letters there. I see nitrogen, capital N, hydrogen, which is capital H, oxygen, which is capital O. And then as far as the number of atoms, we have 2 nitrogens. Again, remember this subscript 2 applies to everything in the parentheses. So I have 1 NH4, and then I have another NH4. So 1 nitrogen plus another nitrogen makes 2. And then for hydrogens, we would have 8, because I have an NH4 and then a second NH4. So 4 times 2 is 8. And then there is no subscript after the oxygen, so there is just 1 oxygen atom there. All right, going back to our learning target here, we want to read chemical formulas to determine the number of atoms present of each element. And if you can successfully answer the practice problems that you've just seen here, then you are able to do that. This is the end of lesson number 1.